Hello, I'm Owen, and I'm here to talk to you about a domain-specific modeling languages for citizen science data provenance. And we'll start with our why. Research metadata, the data about the data. So in 2016, there was a publication of the FAIR principles. And the idea of the FAIR principles was to give a guideline as to how to produce interoperable metadata so that a data set can be easily found and accessed and then reused. And their big goal was the idea that if people could document the processes that they used to create their data sets properly, then more people would reuse the data set and everybody would get a little bit more use out of it. However, citizen science is an area which creates data sets that typically are not trusted. Now, these are projects that would normally involve non-scientists. So a citizen could fill in a survey on, say, species of animals in a certain area, something like that, and submit those to a portal, and you collect the data set through submissions from the general public. Of course, you give them guidelines as to what you're looking for. But yes, typically the data sets that they produce, though, are mistrusted. So ideally, we want to apply FAIR principles to citizen science. And I got 1 minute.
Carry on and we'll...
So we partnered with Earthwatch, and they have a Naturehood UK survey page, which is one example of a citizen science project where they collect this sort of information. That was a laser. So you've created a data set, and the question now comes is to what's your approach to documenting the lineage? And unsurprisingly, do nothing is more common than you'd expect. So this comes down to the idea that there's a lack of knowledge or training around metadata. Nope. You can't see the bit where it says there's an unstructured approach, which basically could be anything from you wrote a paper and you discussed your process in the paper.
Oh, yeah.
Stop that from happening again.
And you say what? Thanks.
Great, thank you very much.
So yes, you just write a document and you say, I did this stuff and here's my data set. And the problem is that may not follow a standard and doesn't necessarily reach the FAIR principles because you've not made it machine parsable, and therefore it's better than nothing, but it's not good enough. And then there's the structured approaches, which typically will use something like a lineage specification. We'll be looking a lot at ISO 19153. They give you a minimum level of detail that you're supposed to be dealing with. They usually provide an interchange format, typically an XML file, and they're complex and they're difficult. And if you're not an expert, you will struggle. So our project started with a discussion about the lineage problem and that this ISO exists. And we discussed how the ISO 19153 is created as an XML file. And we started by talking about the solution, which is these XML files. And as you can tell by that, you don't want to write that with a text editor. So they pointed out that there are form applications that you can use to generate the XML file for you. However, if you want to use this application, you need to know the specification to be able to fill it in and generate the XML. So during this conversation, this is nice XML. Is there a UML model for that? Oh, actually, yes, there is. So we had a UML, we have an example of editors, and we have some text output. And at which point a light bulb goes on and goes, this looks very much like something that you should be managing through MDE practices. So the aim of our project is to try and reduce the barrier of entry to creating these lineage documents, the ISO 19153 file, by establishing a modeling language that we can then use to run generators that create the editors and the text files. And one example will be to output an XML file, but also then we could generate other types of output from the model that's been created. The tool that we want to create needs to be an assistive tool, ideally with a text-like experience, because you're writing a document, you want something that behaves like a document to write. But it must have sort of a form-like structure, some sort of automation, help with auto-completing variables, and give you some hints as to what you're supposed to do next as you're documenting. And the idea will be is that you will model your project once and you'll be able to get multiple deliverables out of it. So we've set up a small project team. That's myself, Lucy, who is our research metadata expert and has some experience of citizen science. There's Antonio, who was at Aston and has since moved to the University of York, hence why I've got two universities. And our partner, which is Earthwatch, where we deal with a nice guy called James, who deals with citizen science project managers. So we have that sort of the user audience that we would sort of be putting this towards. We've elected to use JetBrains to develop our modeling language because mainly it's open source. But we have the structures, editor, type system, transformations, and constraint stuff that we need to create an application that's sort of like a text editor. The MPS JetBrains itself is a text-like editor, and it has cells that you can freely write any text into, and you can skip between these cells like a form, and it will also give you the ability to perform some levels of automation. So you can set intentions. I intend you to do this in this cell. I will give you some options. Do you want me to do this for you quickly, etc. And of course, there's automated validation. So when the user puts the wrong thing in the wrong box, we can point out you probably want to make some alterations. So far, we have done lots of development work. Over on the left here, in this bottom corner, this is the MPS editor that we use to create the language. So we have structures. Every structure then has its related editor panel. And to create your document, effectively, we take several of these structures or in their editor form and stack and nest them together to build up a document whereby you'll be at the top for your details, then your citations, create lists. So we had to extend some of the structures that were available in the ISO, in the concepts for making lists and things. And this compiles, you then get your application. Your application lets you start writing your document, and you can then create concepts within that that you can then reference in your document. So for instance, you'll create somebody's contact details once and you might reference them multiple times during your process of documenting. And after you've effectively modeled the process of your project, you can then generate here just a quick HTML report that gives somebody a human readable report that they can look at. And ideally, yes, you'll also get the XML version. But when dealing with an end user, I need something they can look at and go, yes, I can see my data and I understand how this works. So our next step is to engage with some of the actual project managers at Earthwatch and sit with them for about 2 hours. Talk to them about the idea of how to go about documenting lineage through a modeling sort of process. Introduce them to the MPS editor. Probably need to guide them through it. If anybody hasn't used the MPS editor, it's an experience. But there's a lot of hills that once you get over it, it becomes very intuitive. But things like pressing control and space to a non-developer is going to be an interesting one to explain. We want to know what their thoughts are of this text-like editor. So it's not Excel cells laid out in a sheet. It's going to be in the form of a document, and they'll expand out. And then what kind of outputs do they want? I mean, I can stand here and say, yes, you want the XML. Yes, you might want a HTML page, but do you want a LaTeX file? Are there quarterly reports you have to do? Are there things that once you've modeled a project, you could create other deliverables for? So observations so far, using the ISO 1915153 is difficult. I referred to the specification, guides from NASA and guides from NOA. It's unclear, so you'll typically have to read multiple people's interpretations of what is intended for certain features of the language or the UML diagram, and it's overwhelming. Model representations can be tuned to different audiences, which we think is going to be quite important for this project. The idea is we want people to model with one language and generate one model for their project to get multiple outputs. However, you've got multiple science disciplines that you're going to go to. So we're going to need to create different editors that ultimately back up to the one language, but try and fit as many people's needs as possible. Preferences, I suppose. But modeling tools and lineage specifications share a common problem, which is that they are both complicated, and raising the levels of abstraction help, and automated tooling also helps in dealing with the complexities of what you're trying to do. So our future work is going to be guided by what our citizen scientists come back and say. We've got expectations that we'll probably need some sort of graphical process flow representations. So in the lineage document, you will discuss process steps, inputs and outputs. So there's nothing to say that we can't generate something graphical for that. And what people's impression are with the editor experience. That's going to be an interesting one, because I don't think many people have encountered something like MPS. And if we were to turn this into a fully fledged application further down the line, ideally we'd be looking to go for something that is a cloud-based project modeling tool, because we want to remove the application installation requirements so that we can effectively attract the attention of more citizen science projects, and ideally enable collaborative modeling projects for doing the documentation process. Nobody likes to document. If it's a very big project, there might be lots of contacts, citations, things like that. It would be nice if you could do it as a group effort and everybody could chip in a small amount. And there are some follow-up research grant applications in the pipeline. The aim will be to try and build a standards-based notation for the citizen science community using the MDE tools and support to help them document their experiments and processes. Hopefully I'm on about 10 minutes.